Chapter 1, Section 1, What is Chemistry? And Chapter 11, Section 1, State and State Changes. So what is chemistry? Chemistry is concerned with the properties of chemicals and with the changes chemicals can undergo. So this is kind of our introduction to the term chemicals and our introduction to the two types of changes that chemicals can undergo, both physical and chemical changes. So let's talk about a chemical. So a chemical is any substance that has a definite composition. In other words, it's always made of the same stuff, no matter where the chemical comes from. For example, some chemicals are found naturally. Water is a great example of this. Carbon dioxide is a great example. There are some chemicals that are manufactured. Plastics, for being more specific, would be polyethylene. And there are even some chemicals that are taken from natural minerals, such as aluminum. A chemical reaction is the process by which one or more substances change to produce one or more new substances. These reactions are taking place around you and taking place inside of you. It's what helps living things grow. It's what helps dead things to decay. For you personally, every time you cook food, anytime you perform a lab in chemistry class, when you take a picture, when you strike a match, when you turn on a flashlight, even when you start your car, these are all chemical reactions. States of matter. So matter is made up of particles, and sometimes we can see matter on a macroscopic scale. So in other words, what we can see with the unaided eye. When you mix two things together, if there's a color change, this would be what we see on a macroscopic view. But when we're talking about matter and the fact that it's made up of particles, this is occurring on a submicroscopic scale. In other words, it refers to what you would see if you could see individual atoms. Obviously, in chemistry class, we cannot see individual atoms or molecules, so we use models in chemistry class. So there are models throughout your textbook. There are actually a few models we're going to look at in this PowerPoint presentation. And what this helps us do is to see the arrangement of particles in different shapes of matter in this lecture. We'll see different sizes, shapes, and makeup of particles of chemicals. But the thing we want to keep in mind is we don't want to take these models too literally. They are just a cartoon representation. Atoms are not really different colors. Also, we're limited that whenever we look at these models, they only show a little layer, a single layer. But truthfully, when we have a solid or a liquid or a gas, these are three-dimensional. And also, we want to keep in mind that models are stationary, which implies that particles do not have any motion. And they do. So one of the things you're going to look at in this chapter in class is a model that looks at states of matter. We're going to look at solids, liquids, and gases, and we're going to look at some models of those three states of matter. But before we do that, we want to talk about the fourth state of matter, which is plasma. Plasma is a high-temperature physical state of matter in which atoms lose most of their electrons. So you may recall from middle school class that if we have an atom and it loses electrons, it becomes a positive charge, and positively charged particles are referred to as ions in chemistry. So it's really a high-temperature gaseous ion. Places that are great examples of plasma: the sun and other stars, fluorescent light bulbs, and sodium vapor lamps. The sodium vapor lamps are the lamps that you see along the street. They give off a yellowish glow to them. Lightning, the aurora borealis, also known as the northern lights. So let's look at a model of the three other states of matter. For example, we can look at water in the solid, liquid, and gaseous state. And you may become kind of concerned because when you look at the solid state for water, you see that it kind of has some open spaces in between its molecules. Water is unique in the fact that it expands when it freezes. And we're going to come back to the reason why water behaves this way later in the year. But we can look at another substance. For example, we can look at mercury in its three states of matter. And this is probably more what you expect to see, that solids have tightly packed particles. It has a very rigid structure. These particles have movement, but it's limited to just a vibration in place. A liquid has smaller spaces between the particles. It allows the particles to flow over one another, so it's considered to be a fluid. And gases have a large amount of space between its particles. Also considered to be a fluid because its particles can slide past one another. So I mentioned earlier that matter has two types of changes it undergoes. It undergoes physical and chemical changes. So a physical change does not involve a change in the identity of a substance. It can change the arrangement, the location, even the speed of that substance. And we can basically take physical changes and talk about them in two general ways. One is that a physical change involves a change of state. And we're going to talk about the different types of changes of state in a second. And this actually comes from Chapter 11, Section 1. And physical changes are also a good way to separate a mixture. So chemicals, such as a compound, can only be separated with a chemical change, but a mixture can be separated by a physical change. And we're going to look at the separation of a mixture in model in class. Other things that would be a good example of physical change, so if I have a rock and I hit it with a hammer and it breaks apart into several pieces, that would be a physical change. If I take sugar and I add it to my iced tea and I stir, it dissolves, which would be another example of physical change. So let's talk about our changes of state. So we know basically that there are three states of matter. There are solids, liquids, and gases. And whenever we go in between these different states of matter, we don't make a different compound, it just has a different state. So it's considered to be a physical change, not a chemical change. All right, so if I'm taking water and I put it on the stove in a pot and I turn it on, it boils. And in this case, we're going from a liquid to a gas. The reverse of that is if a gas, when I cool it down, goes to a liquid, I get condensation. So let's think about this. You're standing in the shower and you've just finished taking a shower and you've turned the water off, but the shower curtain is still closed. You have steam, but then you open it up and that steam begins to condense. If I go from a solid to a liquid, this is referred to as melting. And if I go from a liquid to a solid, it is considered to be freezing. Now, later on, we're going to talk about energy changes, and we're going to see that chemical reactions involve energy changes, but changes of state also involve energy changes. For example, so Florida, we know that grows a lot of oranges, and sometimes, like this past year, it gets really, really cold, and it can actually damage the orange crops. So one way they do this is that they spray water on their crops. And as the temperature cools down, the water begins to freeze. That freezing is going to give off energy and keep the orange crop warm. So freezing we would consider to be an exothermic process, and since melting is the opposite of that, we would consider that to be an endothermic process. There are two other changes of state we want to talk about, and that is sublimation and deposition. So the picture that you're looking at on the left has a flask, and in the bottom of the flask you see silver crystals. These are iodine crystals. And iodine has the unique ability to sublime, which means it can go from a solid to a gas. So when you look at the flask, you see this purple haze. That is the gaseous state of iodine. Something else that you're probably really familiar with undergoing sublimation is carbon dioxide. The picture on your right is a great example of deposition. So deposition would be the case of us going from a gas to a solid. So we know that there's water vapor in our atmosphere. And if the temperature gets cold enough, we undergo deposition. So in other words, that water vapor in our atmosphere forms a solid known as frost on our grass during the evenings. All right, so let's talk about a chemical change. So a chemical change is where we take one or two substances or more, we combine them together, and they make something completely different. With very different properties. So the example that I really like to talk about is sodium. Sodium is a solid. It's very reactive. Chlorine is a yellow gas, also very reactive, and we combine them together to make table salt, which you season your food with, so it's very neutral as a substance. So again, take two things with very unique properties and make something completely different with its own properties. A great way to represent this is to use a chemical equation, which we're going to look at, and we're just going to basically talk in this chapter about the parts of a chemical reaction. And the thing that's really important to note about a chemical change is that atoms that are present in the reactants are the same atoms that are present in the products. All that's happened is that we've rearranged those atoms. The other thing to note is that however many atoms are present in the reactants, that's how many atoms are present in the products. So what this really tells us is the law of conservation of matter, that the products, the reactants have a mass, and that mass should equal the mass of the products. So a chemical change does not affect the total amount of matter. Now we're not going to get into formulas here, we're just basically looking at the parts of a chemical reaction. So here I show carbon and, which is represented by the plus sign, oxygen. They react, and that arrow means yields, so I'm going to yield carbon dioxide. So chemical equations always have the same format. Everything to the left of the arrow is the reactant, that's my sorting substance. Okay. Then I'm going to separate the reactants and the products by an arrow, which means yields. And everything to the right of the arrow is my product. Now in this case, it only has one product, but we could have multiple products.